good time to check out.
We did not have any questions on the chat yet.
No questions. I can't be that good at explaining things. Maybe or maybe we just haven't got to the to that part yet. Um so think I think we were on filters. Yes. Yes, thank you. Thank you, Taylor. So they have a filter in their system that's similar to a mini split system. It's like a kind of that wire mesh filter you pull out, you wipe off every once in a while. It's not a huge deal, but it is one of those behavioral adjustments. Nobody is thinking about having to change a filter on their water heater. We're not used to that. A lot of people don't know. It's an important thing to tell people because if you don't, and also tell your installers, because if you don't, you can end up with something like we have on the top here where you can kind of see that black line right on the top of the tank. That's the filter. And you can see that there's a pipe over it. You can't pull that filter out of this system. And so you may end up just, you put this in, everything is great. 6 months later, it is no longer great because you can't change the filter. It just can't get cleaned. The heat pump's getting starved for air. Stuff starts not performing and maybe breaking if it's extreme enough. Um, so it's just one of those little behaviors that you need to tell people, hey, this is the thing you need to do now. It's a best practice. Um, and if you do that, right, we've got our picture on the bottom here where it's got a nice open space. It's got a lot of air to feed. The filters are accessible. Everything is really easy to service. Um, and stuff like that goes a long way. If you install it right, it's sized right, you're going to end up with an end user who has a nice, happy, long life with that. The heat pump water heaters are designed for a lifespan on a unitary system of 10 to 15 years, right? And that's true of all water heaters. They're not any different. It's just a slightly new technology. So our best practices here are we want to make sure we're sizing correctly, which I will come back to. We want to make sure we're providing a necessary air volume, which will be specified by the manufacturer. We want to make sure our operating temperatures are appropriate, and we want to make sure that we're installing with access. Um, they're so flexible that as long as you're meeting those parameters, you can really find one for just about any project. New construction is pretty easy. We're building for new. The main consideration when you're looking at putting one in a new project is make space for it, right? Find a good place for it. Make sure you have access to it. Design that into your system. Nobody wants after, right? We get through the process of designing these gorgeous buildings and we put so much thought into kind of what the user sees and where they're going to be and how their time is going to be spent. We think a lot less about our support systems like hot water. Designing space for that hot water heater to be that isn't obnoxious, that isn't in the way, is really important now. Having a mechanical space, even though I know it sucks, nobody wants to give up their interior space. Um, it's something you really need to do. These need enough airflow, and nobody wants one sitting in their hallway. So having a place to put it is going to be your biggest concern when we're talking about new. In retrofits, that's more the area of concern because we have a fixed space. We're already working with a system that's been built. And so then we need to find a place to put it. Again, space is our biggest issue there. Um, Suitable locations, right? Just to give you some ideas. I've heard some stuff about California code. I haven't really been able to verify it. I'm up in Washington State, where maybe a garage, you're not allowed to put a heat pump in there or something. That's weird to me. In Washington, we really don't worry about that. The main thing that I would watch out for there is your upper operating temperature limits, right? If you're in a climate that's similar to mine, that's the best place for it. It will always have the temps it needs. It's out of the way. It's, the occupant can't hear anything. It's not making any sort of cold air in their house. Um, that's if you're in an area with a colder climate. If you're down in Southern California, and you have no tree shading, right? Central Valley, there's just fields around it. You have no sun shading. Maybe the insulation isn't great in your garage. Um, that's where you would want to consider putting it somewhere else. Basements are pretty nice. In that case, you get the energy input from the earth. It's always making your basement a little bit colder for you, but your heat pump actually will like that. It won't mind at all. And it's what the heat pumps likes is that it's consistent. It's this consistent energy input. Um, so finished or semi-finished basements, the ground can really outcondition anything that we can build. Um, and like I said, it might be kind of cold and dank for you, but the water heater's going to love it. Just make sure with both the basement, the garage, interior applications, you do have condensate that needs to be managed. It can be one of the nice things about a heat pump water heater, actually, is that they have a little bit of a dehumidification effect. And so having it down in your basement will kind of help dehumidify your basement a little bit, not enough to solve a problem or preclude ventilating it appropriately, but it's a nice little bonus. But you do need to have a plan for where that condensate goes. Down in a basement, you would need a condensate pump, unless you have a drain line down there, and then up on maybe a main floor or something like that. You would want to plan on a route to run it into a drain line. Um, Laundry rooms can be nice places for them. Usually they're big enough. Depends on the laundry room, obviously. But people aren't generally too worried about noise in their laundry room. Doesn't matter if it's a little chilly in there or anything like that. It's kind of a nice, it's sort of the old school mechanical room. We've got noisy machines in there. Sometimes it's a little hotter than you want it to be. Those can be good places for the heat pump water heaters as well. Um, and then finally, if you can get the ducting to the outside and you can get louvers in your doors, you can put them in a more confined space like a closet. Just remember, you take that little efficiency hit, and more importantly, you still need to be serviceable. You still need to have access to your unit. And so, like your hall coat closet that's only wide enough to get the unit, physically you can fit it through the door, and that's it, is probably not the way to do it. Putting it in maybe a bigger closet with a sliding door that has a lot of access on the sides, that'd be great. As long as you've got those louvers in your door, and you would have to duct it to the outside, but there's no reason that wouldn't work fine. All right, so on to our split systems. Splits do not have most of the challenges that we mentioned with the unitary systems, and that's really the big advantage to them is that when you look at sort of the myths and truths section of my presentation here, the splits don't have those. And before I get any further here, I do just want to reiterate there's only one split heat pump on the US market. It's the Senko 2. All of this information is specific to the Senko 2, and the main reason that I'm wanting you to know that and that I bring it up is because the Senko 2 is weird. It's using carbon dioxide as a refrigerant like a commercial system, and that carbon dioxide gives it a lot of properties that I would not expect from conventional systems. I would expect to start seeing split systems from other manufacturers coming out in the next few years. I think they are on their way as we kind of get around operating ambient issues. I can't tell you what those other offerings would look like, but just mental note, right? All of this stuff is specific to the Senko 2. With that out of the way, primary advantage for the split is that it does not have those limitations. It'll run to negative 25 Fahrenheit. You can put it pretty much anywhere outside. I have folks in Alaska who use them. If you're in like Fairbanks or Meadow Valley or somewhere with like really, really cold climate, you get down to negative 30 on a fairly regular basis. You might consider maybe putting it in a garage or something like that. In those situations, you guys are probably a little more used to working around stuff like that. For everybody else, we really don't have a floor, right? We're never going to hit negative 25 in coastal Washington and coastal California. We do still have airflow requirements, But again, it's outside, for the most part. There is a way to put it in your garage, as I mentioned. There's a developed and approved application for those, but generally we're going to put it outside and we don't run into that space challenge. They are pretty quiet. They tend to operate around 37 decibels. Your outdoor unit's not going to drive your neighbor crazy. It's not going to drive you crazy if you hang it on your wall. Um, and I've been to job sites where I've been standing there waiting for the unit to turn back on from a couple feet away, and just I've not noticed. I've gotten distracted by something, and I've turned around and it's been running for minutes, and I never heard it. There really is not a noise concern with these. I'm deaf, but I don't hear very well. But um, there's not a noise concern with them. They are fast, right? So they 20 gallons an hour is kind of their recharge, which is comparable to most electric tanks. They're pretty comfortable for folks to drop in. They don't have filters, so there's no filter to clean. The outdoor unit is built a little bit more like a mini split, where that outdoor condenser, you want to hose it off once a year or so, every once in a while, make sure you don't have a bunch of leaves in it. But otherwise, it's kind of good to go. They're incredibly efficient. COP is generally somewhere between 3 and 5 at our normal ambience for the West Coast. In California, you're probably a little bit more than that. You're a little warmer than we are up in Washington State. Um, Probably threes to, somewhere in there. Um, Split systems are going to leverage water temp for storage. You can do that with unitaries now. They're getting better at it. The split is going to do it by default. It's made to do it. You can't change it. You have to do it that way. And what I mean by leveraging water temp is we store our water with a split at about 140 degrees up to 150 degrees, somewhere in that 10-degree range. And in that case, you would have to mix it down. It's unsafe at 140. You can't have that coming out of your tap. It's against the law. It's not a good idea. If you've ever been in a house that needed a mixing valve and didn't have one, I have. You've burned yourself a couple of times trying to turn your hot water on. So what we do is we store it really hot and then we can expand it, if you will, by putting in a mixing valve that brings cold water in before it goes out to the house. So we're bringing in super hot water, we're cooling it down a little bit to about 120 with some cold water, and in that way you can get a tank that's, 20 gallons more, a first hour rating that's 20 gallons more than the tank will actually hold. We have a 43-gallon tank that will output about 70 gallons if you just turn your hot tap. Um, so that's really nice for areas that have expensive power, time of use rates, especially. You can load up when electricity is cheaper and have lots of storage for when electricity is more expensive. It's also nice if you have power outages, things like that. The split system does have the ability to manually program into your heat pump blockout times. So if you have a really fixed schedule of power is cheap from, 1 a.m. to 5 a.m. or something like that, you can program into your heat pump, hey, I don't want you to work during the day. I only want you to work at night, and it'll do that. And then we also have a Modbus port on the split systems for CTA 2045 connectivity. That might also give it a little bit of home automation stuff. I'm still kind of playing with that. I can't give you a definite answer on that one. Um, Split systems are really low draw. They're really good for off-grid projects. And because we have these largely independent heat pumps and the tanks are unpowered, it's just a storage tank, because we have those two things and they're kind of independent of each other, as long we'll get to that, but we can scale pretty linearly to match needs, right? If you need more output, but you're not worried about a bigger storage volume, you can add a second heat pump. If you want more storage, you can add a second tank. You can do two tanks with one heat pump, right? And so on. Obviously, that's all constrained by your space and your budget and all that stuff, but it's doable. We can get really, really flexible applications out of a split system. Split systems do have challenges. They don't have the same challenges that unitary do, but they do have a couple. The number one is probably the cost. They cost more, a fair bit more than even a high-end unitary system. They are expensive. Carbon dioxide, when we use it as a refrigerant, has to operate between, 1200 and 1400 psi. And that's insane. I don't really have a great reference for you. Your tires are like 30 psi, maybe up to 50 if you drive a big truck or something like that. 1200 to 1400 is insane. If you have somebody coming out and doing field work, they're not going to be able to work with a 1200 and 1400 psi system, which is okay. These are factory sealed. They come pre-charged. They're sealed up. There's no way to interact with the refrigerant loop anyway. Um, but to give you a reference for why they're so expensive, all those components that are dealing with that refrigerant loop have to be rated to deal with that pressure. And then the tanks are made of stainless steel, right? Everything is really, really high quality. Everything is rated for the work that it has to do. But because we have some kind of extreme conditions, that makes things expensive. It's a really, really good product, but you do pay for it. Um, as I have subtly and tastefully noted here, let's talk about research for a second. I very much would like to talk about this because every person I talk to in California seemingly cannot live life without a research system, and that's okay. I know it can be a code requirement, and you can have one, but it has to be either one of the pressure sensors that knows when your tap opens up and it's kind of like a little booster. It sees that, oh, okay, there's water coming out of the tap. I better ram that cold plug out. Or it needs to be one of the push buttons. Do not, okay, and raise your right hand. Do not call me, tell me I'm putting a timed or continuous one on there, ask for my blessing, do it anyway, and then call me mad that it doesn't work and you never would have bought it. And how do you fix this? Every single time it will not work. Do not put timed or continuous recirc pumps on split systems, at least the Senko 2s. Like I said, push buttons are fine. I'm not saying zero recirc, but you need trigger ones, and the ones that sense motion are not great. You get a lot of people going into bathrooms more than we have demand for hot water, and they can end up causing issues. And I'm going to get to why. So our next slide is going to talk about why this is, and you'll see why. But I really cannot drive home enough. Don't use timed or continuous recircs with the Senko 2s. Um, they do have some pretty specific operating parameters. So it's kind of like a piece of fabric that'll stretch in one way but not the other. They can be really flexible in some aspects, and then they are really, really rigid in other ways. So we'll talk about those parameters in a second. But it can be a little counterintuitive how they're flexible one way and not the other. That can be a challenge with them when you're designing stuff because there's a lot of things that seem like they make sense, but then they don't work because of the way that the system operates. Um, and usually when you're trying to do normal stuff with them, it's okay. If you're just trying to heat water and you read the install manual, it'll work, right? It's when you start trying to get creative with them, which you can do, and it can be really cool, but there are just hard limits to what they can't do. And again, we'll get to that in a second. Um, Freezing can be a concern with split systems. If you live in a really cold climate, right? If you're up in Tahoe or the mountains or something, if you're not in California, right? If you're up here in Washington, um, you would want to have freeze protection measures like heat trace tape or some passive drain valves. Those are thermostatic valves that the temperature of the water causes a piece of metal in them to deflect and open up. And when they drop below 34, the valve opens up, lets water drain out, pulls in hot water from the tank flushes it through all the piping, and then they close back up and your piping warms up a little bit. Those are really nice for when you lose power. Up here, we lose power when it freezes most of the time. If it gets cold enough, usually those two things coincide. Um, and that's when stuff ends up freezing up. So the drain valves can be a good thing. The heat trace tape doesn't work if you lose power, but it's just one of those things you need to be mindful of. If you do experience a freezing issue with a split system, it'll freeze at the water pump, which is replaceable. It's pretty easy to replace. It's more of an annoyance because, hey, now you have to go buy a water pump and then you have to replace it and it's 20 degrees outside. It's a little annoying. And then lastly, just like the unitary systems, the tanks do occupy space, right? We need to plan on having a place to put them. I know that California, especially, is really used to the instance these days. It confused me at first because I would get calls from people and they would go, where am I supposed to put this? And I go, where'd you put your last water heater? What are you doing? And I didn't realize that everybody had these instant hot water systems. So it's just something to keep in mind. You are going to have a tank, and they're pretty big tanks. They don't need airflows. So, that coat closet in the hallway where you never put anything in the bottom of it and the coats hang up a few feet, that'd be a fine place to put one of the little 43-gallon tanks. Um, but you do need to have a place to put them. So, this slide is going to explain why my blood pressure went up a little bit when I was talking about the research. Senkos are weird. This is not I would like to reiterate when those other split systems from other manufacturers that may use other refrigerants come out, they're probably not going to work this way. But for right now, this is what's available in the US and this is how it works. So the kind of the linchpin of these split systems is that they have a stratified tank. So if you've messed with hydronics a whole lot, in fact, you might recognize that this tank is basically a potable rated 4-port buffer tank that you might have in a hydronic system. We're feeding cold water into the bottom of the tank from the city, and then the heat pump will pull it out of that same bottom of the tank out to the heat pump. It'll heat it up, and then it'll drop it at the top of the same tank with nothing separating it. It's just that thermal stratification keeping your hot water floating on top of your cold water. And that's pretty normal for most water heaters. They all sort of do that, but most water heaters will do it with what we call a dip tube, where it's coming down from the top of the tank and it's floating it on the bottom. When it comes in from the side, it has a habit of, especially if you're using something like a recirc that's moving a lot of water pretty quickly, pulling out of the top, pushing it in at the bottom at the same time. You can end up with this sort of swirling mixing, and your tank ends up not being stratified anymore for a while. It will go back to that stratification after a little bit. It'll sort of naturally filter itself out, go back to the way it was. But that's not going to help you if your recirc has been running and you want to go take a shower. The issue that you run into with the splits is that the water on top is about 150, the water on the bottom is about 50 degrees. When you end up destratifying your tank, it mixes down to like 120. And that's fine if we don't have a mixing valve in our system. But it's a legal requirement, it's a safety requirement to have that mixing valve in the system. And so when you put that 120-degree water through your mixing valve, it mixes down to like 100, 105. And people get mad because their showers are a little bit cold. We're not used to that. Um, and the set point on the heat pump is actually 113 degrees. So even worse, when you're destratified down to that 115, 120, the heat pump's not kicking on. It's not sort of trying to fix anything because it thinks, no, my tank is 120 degrees. I'm okay. I'm not saying that the manufacturer of this isn't going to change that sometime, that, there's not different ways to do that. There definitely are different ways to do it. I would really like to see maybe some things being addressed there, but for right now, that's the way they work, and there's no way to change it. You really have to be aware of it. That's why recirc pumps don't work. That's why some of those funny little things that you might think you can do um, would work out, and they don't end up doing it with the split systems. But the things you can do with them, split systems are really characterized by flexibility. They have a pretty limited product availability, right? They've got one heat pump, there's 3 tanks, and that's kind of it. But we can take those parts and pieces and we can use them and get really, really flexible systems out of them because they're modular and they'll operate in just about any ambient temps. It's a pretty simple installation and they're high output. So Scaling them for your project is very doable if you need, but for most projects, just sizing them right, you can basically just drop in one heat pump and one tank, and you'll never see the bottom of your hot water. So domestic situa or just normal domestic hot water situations that they're made for, they really shine in. They're hard to beat for that. Um, and then also critically for those jobs that have those space concerns, maybe we're looking at a unitary system instead. Um, but you just have nowhere to put it. A split system would be a good fit in that case because we don't have to feed the tank a bunch of air. It's just a storage tank, so you don't have to run 230 through all of your interior walls to just that one weird place you can put the tank. Of course, you got to get piping down there, but you don't have to wire for it. You just wire for your heat pump outside. And those tanks can really go just about anywhere. We can even put them outside in some climates, California especially. You want to make sure that they're sheltered, right? Build a little roof over them so just they don't get rained on, or if you have a little shed, you could put it in. But we don't have to have it inside the building, which can be really nice if you have some pretty extreme space concerns. So So another kind of less used but still handy property of the splits is that, like I said, you can actually put that heat pump inside if that's advantageous. If you, for whatever reason, like maybe you are in Fairbanks and maybe it does get really cold, you could put that heat pump in a garage or a basement. um, very critically with those, you would need to manage your condensate. The split condensers can produce about a gallon of condensate or more over, sort of its operations in a day. You need a place for that to go, and they do need a little bit more airflow than a unitary system. They're closer to that 800, 850 cubic feet side of things, but you can put those condensers inside. And then they do have some very limited space heating potential because they make really hot water and they work pretty fast and they have lots of storage. That is its own class. I'm not going to get too far into that. They do have a space heating application that's approved, it's warranted, it's all good. Um, the main thing to know is that it's very low load. So think like 1 ton, right? Not most people. You could do it for comfort in most situations, but you couldn't use it for a primary. And that's one of those things. Just if that's of interest to you, call me and I will be happy to talk to you about it, do a consultation, and sort of talk to you about your project. Planning for your split systems is pretty simple relative to a unitary system. They're a lot easier to just drop into a retrofit. We don't really worry about space. We don't worry about airflow. You do need to make sure that your heat pump goes somewhere that it'll get airflow, which usually just means a couple of feet of clearance on the sides. You can actually hang one on a stand. So the pictures I have here, you can see one. That's one running in the snow. That's one sitting on one of the heat pump brackets that hang on an exterior wall. And then we even have one in a garage here. So that's kind of all three implementations. Um, you don't want to put them straight on the ground. Do plan on having a bracket for them. They have an air bleed valve underneath that you need to access. And if you're up in Tahoe or something like that and you do get snow in pretty meaningful amounts, you do want to make sure you're hanging it up over your snow line because it will interfere with the condenser's ability to breathe. And then if you are in Tahoe or cold climates, they do condense kind of a lot depending on ambient humidities and things like that. So just make sure you're not leaving this big puddle of ice on your sidewalks. It's not, it's one of those things, and there's a lot of these things with heat pump water heaters where none of it is this huge, massive emergency thing that you have to figure out right away, but it's all important to think about. It's just these little details where you got to make sure you get a couple of things right, and then everything's fine. So making sure that you're not turning your sidewalk into an ice rink is one of those details. It's just something you have to think about with these. And then again, you got to make sure you're putting freeze protection on it if your design temps are below a certain point. I think it's 37, which is most of the U.S. Um, So another thing with planning, not to beat a dead horse, but again, research, no timed, no continuous. I don't really want to talk about aquastats. Technically, they are okay. I have had more issues with aquastats than I have had success. I would, if you can put a push button in, that's the way to go. Um, and then plan on having a disconnect for your heat pump. Just like you would with a mini split condenser, you have to have that. That's a legal thing, safety thing, and just a good idea. Um, and a disconnect, if you're unfamiliar, is a box that hangs on the wall. You run power into it, and then there's like a little plug thing in there where if somebody needs to go service the unit, they pull that plug out, they flip it over, and then there's no more power going to the unit. It's just like a switch, but you have to be really consciously, you know, activating it. Nobody's going to stumble along and accidentally pull your disconnect. Um, but you are going to have to run one, and that can add a little bit to your installed cost. So sizing, and I put a split picture on this, but this is true just sort of generally. So sizing for split and uh, more importantly for the unitary systems. We'll get to that in a second, but sizing is just critical for heat pump water heaters, for splits, for the unitaries. We have a little bit of a different behavior, especially with the unitaries. And so sizing right can help bridge the gap that people sort of run into where they're used to a gas tank. They've never seen the bottom of their gas tank, and they don't understand why they run out of hot water when they take a half-hour shower with a heat pump. Um, it sounds a little silly when I say it that way, but it's a real thing, right? It's people's houses, it's their comfort, and it's something that bugs people is running out of hot water. Unitary systems are usually recharging, if they're heat pump only operation, they're usually recharging at like 10 to 14 gallons an hour. So it's about half what you would expect from an electric tank. They're a little bit slower. And you can put it in that turbo plus mega mode that we talked about and get it up to about 20 gallons an hour and use your backup elements and just use a little bit more power. Um, but that does impact your efficiency a little bit, to just have it running in turbo mode all the time. So we want to make sure that we're sizing a little bit larger, especially with the unitary systems, than maybe we would with like an electric tank or a gas tank. Manufacturers will tell you, hey, this is, if you have this occupancy, you want this tank. And it does vary a little bit, so I can't really give you a blanket. But going with their sizing and then also considering, you know, Christmas, do we have 800 people coming over for the feast? Somebody stays the night, takes a shower, right? How many showers are we going to have to give out on our busiest day when all the kids come home, when family are visiting, we throw a party, something like that. So it's usually good to size more like 120, 130% of your occupant load to get enough storage to help you kind of bridge those high capacity days. Otherwise, following those manufacturer recommendations, you can get by pretty well with, if that's actually the people in the house, right? If you have two people in the house and you follow the 2 to 4 people suggestion, they really shouldn't see the bottom of their hot water. Um, for split systems, less of an issue because those tanks are kind of big by default. They're medium to enormous. The 43-gallon tank with a 70-gallon first hour rating is good for just about everybody. They recommend them for 2 to 4 people. The 83 gallon is generally rated for 5 or more people, and then the 119 is really designed for that space heating application. That's kind of the only thing they size it for, but realistically, if you have a really big family, if there's like 7 or 8 people, that 119 is probably the way to go. Otherwise, the 43 or the 83 would be okay with a split system. But just to drive home, making sure you're sizing correctly and making sure you're sizing a little bit over what your actual occupancy is will help with those busy days. And it will also help when folks go to sell that home and maybe somebody, they only have 2 people, but somebody with 3 kids is going to buy the place. It can sort of help out with that transition as well. And then finally, we're going to kind of end with step one here and talk about client expectations and education. And so with all new technology, we are like 10 times more impacted by horror stories from issues that folks have had than we are from the places where things are successful. There's really a bias towards remembering those bad things. Um, and I run into it all the time. One of the causes of all these horror stories, where especially, I get these calls all the time, like I said, folks who are really scared, they're upset, they think they're going to need to spend thousands of dollars to fix something that they barely knew they had. They've never thought about their water heater before. They don't want to start thinking about it now. Um, or even worse, they've turned something off and their whole house is broken because they didn't know what it was, and then their whole house doesn't work right. Um, I'd say that 90% of these calls that start really escalated and really panicked and really upset end happily and really only take me saying, "Oh yeah, no, that's normal, right? It's normal for it to be kind of cold in there. It's normal for it to make a little bit of noise when it operates. Here's what that does. Here's why it does that. Here's what you need to know." And once you explain that stuff and people know how things work, they chug along happily. Everything's good. But we run into those issues where nothing got explained in the first place, and that's why we're sort of having these issues now. So, a big piece of putting a heat pump hot water heater in now, this is going to change over time because people are going to get used to it. But doing it right now, we need to start explaining you have a filter. If you want it to run a little faster, if you're having a party, hit this button right here. If you really want to prioritize your energy efficiency, it's got this cool feature here. You put it in eco mode. Explaining that stuff goes a really long way because water heaters are a little bit more interactive than they used to be, and homeowners don't know what they don't know. It's really important to educate your client, but also to sort of get to know them and their expectations. Noise level is a big one. Like I say, the water heaters are getting a lot quieter now. Usually they're down like low 40 decibel range these days, which isn't terrible. It's like it's like a fan. Um, but there's folks out there who really don't have tolerance for that. Um, Especially when if it's a high performance building, it's going to be really noise insulated, and so every noise that's in the building is going to sort of be perceived as greater because there's nothing for it to kind of blend into in the background. But then there's people like me. I have 3 kids. I have a bunch of cats. My house is in high performance, and I've done a lot of industrial work over my life. I can't hear anything anymore. So it wouldn't bother me, but it might be a deal breaker for a client. And if it is, maybe that would be a case for a split system. Um, how much water do they use, right? Is sizing for 120% going to be enough? I was just out at a job site where we ended up with 2 80-gallon tanks because there was like a 200-gallon bathtub. And you just have to take those things into account when you're sizing. Um, are they targeting performance standards, right? What kind of energy payback are they expecting of their system? Um, we're looking more at something that's kind of a band-aid where like they kind of have to do a heat pump water heater. So we're doing one that's going to sort of bridge that gap a little bit better for them. Or are they full on like I'll take a sponge bath to save water, let me add them. Again, there's people that exist on both ends of that spectrum, and it can be really good to know your client and how willing they are to modify their behaviors or unwilling in some cases to live with a unit. The split systems are definitely going to be a lot easier to drop in and have nothing change for your end user. But it's worth having a discussion with them and figuring out, what the best fit is, because there's a lot of units out there. And with that, I have sort of come to the end of my slides here. So let's go through some of our questions here. Let's see. Does the local water TDS have an impact on the use of the CO2 split system? I'm not understanding TDS, and I'm sure I'm just missing something simple. I apologize. It has been a morning, but I don't quite understand the TDS. I will come back to that. Maybe it will pop into my brain. So, airflow is so important. A multi-pump unit in northern BC was installed on a shed roof of a MURB with insufficient airflow. Not only froze up and froze the door closed. Yeah, it's basically a refrigerator a little bit. It's makes things cold. Dissolve solids. Thank you. Yeah, water quality is really important for split systems. They have acceptable parameters. And what ends up happening with them is that you get scale buildup inside of your heat exchanger. Um, it really can be an issue. Um, what you need to do if you do run into that issue is descale it. And we do have folks who live in areas with really hard water and they end up descaling their system regularly. And as long as you're doing that, it works okay. But you will experience issues with performance and you'll start experiencing the unit throwing codes over time if it's not taken care of, if it's not managed. Some folks deal with that by softening the water before they feed it in. Some folks deal with it by descaling. I would probably deal with it with the water softener because that means I don't have to do anything except deal with that water softener. But it is something that you need to consider, and they publish the parameters that they consider to be acceptable. So you could take a look at it and compare that to your water quality where you live. Um, and then I think that's it for questions. Hang out for a minute and see if anything pops in, but it's all if you want to do your do your thing. I forgot to put your outro slides in here, so I
Yeah,
apologize.
no worries. Folks, thank you for tuning in and dealing with our technical issue this morning. Really appreciate it. I'm going to launch a poll. If you could fill it out for us. Any feedback is super helpful. And then I'll drop the link to our calendar. There's some really interesting sessions coming up. And if you have any AIA questions, there's some AIA units available for this class. So I'll drop my email and the link to our calendar. But nothing else for me either. Thank you, Eric. I really
Awesome.
appreciate you hanging
Yeah,
on.
yeah. Somebody was asking actually, so we send out the slide deck, right?
Yes,
Okay. So yes, Al, we'll send out the slide deck.
and the recording too. We'll just add the first part and the second part together, and hopefully we didn't miss anything.
Okay. Awesome. Well, if you would like to reach me, I am Small Planet Supply. If you Google Small Planet Supply, we'll pop up. It'll have our number. Call the office. It's either me or Rick who answers. If you have more in-depth questions, if you're kind of looking into splits, or we also carry the LG one. If you have questions about those, give me a call, or just sort of building science stuff in general. I like to chat obviously. So give me a call if you need. Thanks.
Awesome. Have a great day all.
Thanks, everybody.
Bye.